Why does a block of iron sink while a chunk of foam shoots back up no matter how hard you push it under? In the energy filament theory, buoyancy isn't water kindly holding up light stuff. It's the fluid rearranging itself to make its own tension pattern as cheap and even as possible. And low-tension objects get shoved to where they bother it least. Think of the water as made of tiny squishy cubes stacked on top of each other, each cube helping carry the weight of everything above. When you stuff a soft, low-density foam block deep into that stack, it's like forcing the weakest worker to stand in the heaviest lifting spot while the strong ones are stuck higher up. The tension ledger hates that. So the surrounding water pushes from all sides, swaps places layer by layer, and ends up bumping the foam upward into a shallower, low-stress zone near the surface. That pop back up you see is just the fluid fixing its own load sharing. Iron flips the story. Each bit of iron already carries a lot of built-in downward tension per volume, like a worker who shows up already carrying a huge backpack. If you keep iron near the top, the water underneath has to live with a very ugly combination of its own weight plus the irons. And the ledger looks bad. It's cleaner if the iron sinks into deeper, high-stress layers and more low-density water is allowed above. So the fluid quietly urges the iron downward until the overall tension pattern smooths out. Archimedes' weight of displaced water in this view just means how much deep zone tension the object takes over from the fluid decides how hard the fluid will push it out of its own body. The same logic lifts a hot air balloon. The atmosphere is a tension sea with denser, tighter layers below and looser ones above. The hot air inside the balloon is a lower tension patch wrapped in fabric. The cooler air around it would rather sink a bit and let this lighter patch move up into the softer layers. So in this picture, buoyancy is never the fluid generously holding you up. It's the fluid ruthlessly optimizing its own tension map and relocating low-tension guests to the floors where they cost the least to keep. Tap follow, share it on New Physics, Clear Universe.